In this video, we will be discussing how to add an additional site to a Voronoi diagram. So in the last video, you should have explored how to create a Voronoi diagram using 3 sites. And just to keep things simple, I kept those sites the same. So we're still looking at site A, B, and C, which we explored in the last video. We're now just adding a new site, which I have arbitrarily plopped down at the point 2, 3. So we're adding site D. The first thing that we want to do is just concentrate on the cell that contains the new site. So the new site, D, is contained in cell B. So we're only concerned to start with with the points D and B. And we're going to construct a perpendicular bisector between B and D. So here it is. This dotted red line is a perpendicular bisector BD. So you can see that it's cutting through cell B. What we want to do is identify new vertices wherever the perpendicular bisector hits an existing edge. So these black lines were the edges that we constructed when we had 3 sites. Where this perpendicular bisector meets those edges, we are going to construct 2 new vertices. So here's a vertex, and here's another new vertex down here. We can find the coordinates of these vertices by solving the system of equations between the perpendicular bisector BD and the equations of the existing edges. If you're not sure how to do that, check out my YouTube channel. There are some videos there on solving systems of equations using your calculator and by hand. So we've identified those new vertices. What we want to do is take a look at the cells that touch these new vertices. So over here, we've got cell A. So we know we've got to do something with cell A. And over here, we've got a vertex that's touching cell C. We know we've got to do something with cell C. What we want to do is, having identified those cells, we need to construct perpendicular bisectors between the new site D and the sites contained in each of the cells. So we need the perpendicular bisector AD, and we need the perpendicular bisector CD. So again, we're skipping through the nitty-gritty, but we have these perpendicular bisectors AD, which happens to be a nice vertical line. And we have a perpendicular bisector here, CD, which happens to be a nice horizontal line. I'll leave it to you to wonder why that may be the case. So we have these perpendicular bisectors. We need to trim them in some way. This looks very complicated. So we need to trim these perpendicular bisectors so that they're contained within the proper cells. When we do that, as you'll recall, we want to get rid of the portions of these perpendicular bisectors that are closer to an arbitrary site than they are to the sites that they're concerned with. So for instance, this perpendicular bisector, this horizontal line here, AD, the portion that extends beyond this vertex is closer to site C than it is to sites A or D, so we're going to remove it. We're going to do the same thing with the portion that extends into cell B. We don't need that portion. We are going to do the same thing here with the portion of the perpendicular bisector CD that extends into cell A and that extends into cell B. And we're also going to remove the portion of the perpendicular bisector BD that extends into cell A and that extends into cell C. So cleaned up, that looks like this. So we've removed those portions of the perpendicular bisectors that we didn't require, and we're starting to get something that looks a little bit neater. We're starting to get something that looks intuitively like it could be creating cells A, B, D, and C that contain the points that are closer to each of those respective sites than they are to any other site. However, we no longer require these edges from our original 3-point or 3-site Voronoi diagram. They're kind of outdated. We don't need them anymore because we've added this new site D. So we're going to trim those as well. And what we're left with is this brand new Voronoi diagram, which contains 4 cells. We've added this additional cell, D, and the points contained within this cell are closer to point D than they are to either A, B, or C. And here it is. So cleaned up a little bit here, you can see we have this nice clean looking diagram with 4 sites, A, B, C, and D, and the cells that surround them.